Welcome back to Electrosphere AI Tech. In this video, we explore how AI is transforming smart grids by improving energy distribution, reliability, and efficiency. AI optimizes power distribution by processing real-time data from smart meters, sensors, and IoT devices. It uses advanced algorithms like neural networks and reinforcement learning to analyze consumption patterns and forecast demand. AI performs real-time demand forecasting using techniques like time series analysis. It identifies peaks, adjusts supply, and optimizes energy flow, preventing blackouts and minimizing energy waste. AI enhances fault detection in smart grids by using machine learning models to detect anomalies, voltage fluctuations, and power line damages early. AI optimizes energy storage systems by balancing energy loads. It manages battery charging cycles, ensuring optimal storage levels during peak and off-peak hours. AI uses reinforcement learning to dynamically manage battery charge and discharge cycles, extending battery life and maintaining grid stability. Algorithms like Q-learning and deep Q networks, or DQN, are used for dynamic load balancing. AI integrates renewable energy sources into the grid efficiently, predicting output variability from solar panels and wind turbines. AI models predict weather conditions using data from satellite imagery and IoT sensors to estimate renewable energy production. AI-based optimization algorithms adjust energy distribution in real time to maintain stability. For engineers, AI-driven smart grids offer better monitoring, quicker fault resolution, and improved energy efficiency. AI is making smart grids more efficient, reliable, and sustainable. In our next video, we'll dive into AI in industrial automation. Stay tuned.